With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is maximum power transfer to the external circuit in the watt will be. We have to find the maximum power transfer to the external circuit in watt. Clear? Now, before that, we have to find the R equivalent. We can see that this is the infinite circuit. So for infinite circuit, we can find the R equivalent. So let us consider this part of the circuit. This part of circuit, total resistance we can consider this is equal to R equivalent. Clear? So in this way we can find the R equivalent of this infinite circuit, this type of the infinite circuit. So we can redraw this circuit. So if we redraw the circuit, we can see that this is the 3 ohm resistance, and we can draw, and this is what 6 ohm resistance we can consider, and then this is what 5 ohm resistance we can consider, and this is what 4 ohm resistance we can consider. This is the 4 ohm resistance, and this part we have assumed R equivalent. So this is what R equivalent we can write. Clear? So this is the R equivalent, and this is what 3 ohm, 6 ohm, and the 4 ohm, and this is what 5 ohm. So if this is the R equivalent, then we can see that this is also equal to R equivalent. This total is also equal to R equivalent because this is the infinite circuit. So up to this is the R equivalent, then this is also R equivalent we can see from here. So we have to find, in this way we can find the R equivalent. So how we can find the R equivalent? So this R equivalent is equal to, from here we can see that R equivalent is equal to, from here we can say these two are in the series, we can say, sorry, these two are in the parallel, 6 ohm and this R equivalent are in the parallel. So how we can find this? So from here we can write this is equal to 6 into R equivalent and divided by, we can write 6 plus R equivalent we can write. So this, now we can see 3 is in the series with these two. Clear? 6 and R equivalent. So this is what 3 we can write. Clear? Now we can see that this 4 is the parallel with this part of this circuit. Clear? So from here we can write, now R equivalent of this part is what? This. Now we can write total of this. So how we can find? So this is what? This part and 4 is parallel. So we can write in this way. We can write in this way. 6 into R equivalent and divided by, we can write 6 plus R equivalent and plus 7 we can write. Clear? Now we can see that 5 is in the series with the remaining part of the circuit. So this 5 we can write this. So in this way we can find the R equivalent. So we can see that from here we can write this R equivalent is equal to this. Clear? So from here we can find the R equivalent. Now R equivalent minus 5 is equal to, we can write 6 into R equivalent and divided by, we can write 6 plus R equivalent and plus 3 into, we can write 4 and divided by, we can write this is what 6 into R equivalent and divided by, we can write 6 plus R equivalent and plus, we can write this 7. Clear? So we have to solve this, and after solving this we can find the R equivalent. So from here we can write R equivalent and minus 5 is equal to, we can write this is equal to 6 into R equivalent and plus we can write 3 into 6 plus R equivalent and into 4 and divided by we can write this is the 6 R equivalent and plus we can write 7 into 6 plus R equivalent. This we can write, clear? Now from here we can see that R equivalent minus 5 is equal to 24 R equivalent, 24 R equivalent, and we have to multiply by 4, and this is equal to 12, and 12 6 ja 72 we can write, and plus 12 R equivalent. 12 R equivalent and divided by we can write this 6 R equivalent and plus we can write 42 and plus 7 R equivalent we can write, clear? Now from here we can write R equivalent and minus 5 is equal to 36 and 36 R equivalent and plus 72 and divided by we can write 13 R equivalent and plus 42. So from here we can find the R equivalent, and R equivalent is equal to 0.5 ohm. Clear? After solving this, we will get this 0.5 ohm is the R equivalent. Clear? Now we have to find the maximum power. So for maximum power, in case of the maximum power, this resistance is equal to what? 0. So from here we can find the current. So current is equal to I is equal to we can write V and divided by R. So V is what? According to this question, this E is given, and this E is equal to what? 10 volt is given, and this R internal resistance is given, that is equal to this is what? 0.5 ohm is this value, and this is what? 10 ohm. So this is equal to V. V is what? 10 volt we can write, and divided by this R and plus R equivalent total resistance. So this is equal to 10 and divided by 0.5 and plus 0.5 we can write, clear? This. Now from here we can write this is equal to 10 ampere. So this is what? Current. Now we have to find the power. So power is equal to what? P max we have to find. So P max is equal to I square into R equivalent. I square means 10 square. R equivalent is what? 0.5. So after solving this, we will get this is equal to 50 watt. Clear? So this is the required answer for this question. Clear? Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.